Welcome, everyone. This is the Fireside chat on Windows on ARM. I am Lina Iyer. I lead the Windows on ARM group at Linaro. And it's been 4 years that we've been working on Windows on ARM with our esteemed partners here. And so this warrants a discussion on what has happened so far and where we go next. It also coincides with an year since Copilot Plus PCs have been launched and developers have actually started using Windows on ARM laptops for their regular day-to-day work. So it's a good time to take a look at what has happened so far and how do we go forward with this. First, a round of introductions. And I'm Lina Iyer. I'm the Director of Platforms and Virtualization, and I lead the Windows group at Linaro. And with me, we have Marcus. I'm going to read it out so it's easy and I don't miss anything. So Marcus is engineering manager at Microsoft, leading a team that shapes the future of ARM ecosystem through collaboration and partners and community. His focus is ARM software ecosystem development, enhancing media experiences, making AI adoption a reality for all independent software vendors, and ensuring the right samples and docs are in place. That's very important. We have Dileep, who's the staff software product manager at Qualcomm Technologies Inc., where he works as part of the Windows on Snapdragon team. He's responsible for leading the development and management of tools and APIs tailored for developers, executing developer-centric initiatives, and fostering an engaged developer community. Welcome. We have Dave Whaley, who's a director at ARM, whose focus has been on performance, support, and optimization for the most important software and tools within the Windows and ARM and Android ecosystems. He is currently helping drive ARM's developer recruitment efforts and streamline the developer ecosystem for Windows and ARM. And to wrap it all up, we have Francesco Siddi, who's the CEO at Blender. He loves developing products, online platforms, applications, and film production tool. And if you haven't heard of Blender, like I hadn't until a couple of years ago, Blender is an awesome tool for 3D video production and editing. And Blender was instrumental in creating a movie flow, actually won the Oscar for animated feature. We do have a short video on Blender that could run.
Yeah.
And the Oscar goes to...
Thank you to the Academy. Thank you to Sideshow and Janus. Thank you to Blender. Thank you to my mom and dad. Thank you to my cats and dogs. I'm really moved by the warm reception our film has had, and I hope that it will open doors to independent animation filmmakers around the world.
Awesome. So I want to start with Blender. Blender was one of the first projects that we did, and that was the most extensive project that we've handled as part of the Linaro Windows group. And I want to ask you from your perspective, what were your pain points, or what was the struggle in porting Blender into a new Windows on ARM platform from the Blender side of things? Obviously, we have Anthony, who developed most of the Windows aspect of it, but making Blender available for Windows on ARM, what was your experience?
So my premise that I want to make is that obviously my role is also more on the product side of things besides the engineering. So my insight is, in a way, it's good that it's a little bit limited, because then when the struggle is very visible, then I actually see it physically manifest itself in developers banging their heads against the desk or the wall, and then you know that there is a problem. Or if there is no banging, it means everything is going great and Anthony's doing a great job. And the amount of banging for this kind of project was like, relatively okay. The challenges, I think, are mostly with, building the infrastructure to make this possible. And as an open source public project, very often, like those are the kind of resources that initially a project lacks. It's like this chicken egg problem where you say, okay, we want to make sure the Blender is available in this next generation of platforms, but then how do we do it? We don't even have the hardware. So we've been very fortunate to be able to, also with a connection that Marcus helped with to work together with Qualcomm and with Linaro to actually make this happen. So I think that, again, the challenges that some of which we were able to overcome are really about building the infrastructure to make sure that the contributions that we get can be tested, can be reviewed, can be accepted, can be iterated on. There is, of course, a lot of specific stuff to the code base itself, which is designed with a specific architecture in mind, and then you have to start abstracting things. Some of those efforts started in the past for another ARM transition, so it was not too bad, but like that is obviously a big topic. And the main challenge, indeed, for a software like Blender is that there are dependencies on dozens and dozens, 70 plus libraries that also magically need to be somehow working and be compiling on the new platform. And that's where we got a lot of help from Linaro to make that possible, especially the hard work of Anthony. So I really want to give him a shout out for his work and the interaction with the developers. So like making sure that all these different pieces come together, that was obviously the big challenge. And that's like something that we keep tackling as the project moves forward.
You mentioned hardware, and that's interesting because Qualcomm was the first to market with the Snapdragon X Elite laptops. What was your experience in moving people who are traditionally used to x86 systems to work on Windows on ARM laptops?
Very valid question, right? The first issues, or at least the pain points that we started seeing, was that app compatibilities, right? Like what I mean by that is a lot of them are native in the x86 platforms, but then some of these apps to run on Windows on Snapdragon platform, there were challenges. So what Qualcomm really focused on is getting some of these apps, work with some of these partners, especially the top 300, give them a white glove treatment, get some of their apps native on our platform. Because most of the times when you go and buy some of these devices, you want your apps to be running smoothly as you expect in any other platforms. So app compatibility is definitely one of the things that we focused a lot on. And secondly, we also focused a lot on making sure the tools are ready for developers to go on start building on our platform. For that reason, a lot of development work was done within Qualcomm as well to make sure some of these tools are supported for the Windows ecosystem. Plus, we also partnered with a lot of third-party tools to ensure some of the open source contributing happens and the process is continued for this whole developer ecosystem to evolve.
So one of the things that we have as an intermediate stopgap is ARM64 EC. How much was that important to you in your getting the system accepted, getting Windows on ARM accepted?
Yeah, no, that's what we were recommending to all our partners, right? Like, for example, you can have a mix of ARM64 EC, plus you can have this legacy x64. It kind of gives that option for you to choose which part of your code to be compiled versus be running in an emulated mode, right? So this way, a lot of our partners were not, like scared to try this out or spend some cycles in these engineering efforts. And ARM64 EC adoption, as well as in apps and games, was a very important step for Qualcomm to get all these partners running on our platform. Yeah.
So Dave, talking about ARM64 developer resources, what facilities are available from ARM to help transition application developers from legacy x86 to ARM64 natives?
Absolutely. Yeah, I mean, I think we've supported a lot of the work that Linaro's done, helped prioritize the packages and libraries and things that frameworks that ended up getting moved over to compiling natively. Another thing that we've done, we've also taken our performance libraries and our ARM compute library and made sure that those are working well under Windows on ARM because it supports high performance compute. There's more and more workloads that are more compute intensive. So having that or those libraries available absolutely helps. And I think we're going to start seeing more, desktop, hopefully at some point workstation, types of devices where those workloads are going to be even more important. So those are some of the things that we've done alongside, supporting pretty much everything that Linaro has done.
So those are all good positive points. I want to ask you, Marcus, about some negatives of what were the bigger pain points, what were missing in this past year that we had to struggle through to get Windows on ARM accepted.
Well, the Windows on ARM ecosystem is coming forward very well. So in terms of the struggling points, we're looking at some, maybe not first steps, but what comes next in terms of making sure this is a mature ecosystem. Some of the areas we're focusing on around compiler performance, we're seeing maturity in the LLVM toolchain, and less maturity in some other areas. GCC, we've announced 15.1 with ARM support just recently, and that's the first step to getting a better compiler. But first step, if you've looked at GCC, it's a massive piece of work, and that represents 18 months of our work to get to that point. Getting it to a point where it's actually a viable tool in the market is some way away still. So focusing on fundamentals, getting the compilers in place, making sure the libraries are performant. Those have been some of the areas we're focusing on. But if you look at the ecosystem and the example of Blender coming on board, it's a good litmus test as to where we're at. We're not at the fundamentals, we're at the complex apps. So we're way beyond the beginning. And actually you can today pick up a Snapdragon-powered Copilot Plus PC and use it as your daily driver and your daily development environment. The dev tools are there. There's still some areas that you're going to trip over, but it's pretty mature.
Thank you. But so as a developer, what are the things that Snapdragon laptops today provide, but developers don't tend to use, and as a result, we see all these things that are missing or not performing adequately?
Yeah, so actually, Marcus raised a couple of good points. Some of the things that developers are missing out today, I would say, is that especially on the CPU and GPU, they're not really exploring the optimizations because Windows on Snapdragon is actually devised to work in the low power mode. So in order to do that, highly optimized code actually helps them to run better on the platform, which is beneficial for the consumer at the end of the day. So CPU optimizations, GPU optimizations is one thing most of the developers miss out. Another thing that I would want to say is that the utilization of the NPU. So we have a big differentiator, which is the NPU, where you can actually push all your AI workloads. And a lot of developers who are testing out AI on our platforms are still falling back to CPU and GPU. So utilization of NPU, running our all the Gen AI models or the traditional models on our NPU is the best way to utilize the platform, which I think the developers are getting educated about this NPU and how to run on the NPU. But I think there's still a long way to go where they move away from the traditional CPUs and GPUs to the NPU. So I think these are the top two things that developers can leverage the platform better in order to run some of their applications.
Good. Are there any resources available from ARM and Qualcomm on where can developers go for resources that are specific to ARM architecture?
Sure. I mean, there are. I'll take that one first. There are resources available online. We have what we call learning paths. I think that might have been mentioned earlier in one of the keynotes, but there's very specific paths of development that people can follow. There's also developer.arm.com that has some examples, code examples, those sorts of things. we try to make sure that we listen to the developer. If there's something that they're blocked on, we try to prioritize that. We bring that to Linaro and try to get that sort of pounded out. But the idea is really we're trying to put as much support online as we can, so it's sort of self-serve, on demand. So if there's a problem that they encounter, that's how we try to deal with it.
Yeah. I would like to add a little bit more on the AI side of things, because he did cover a lot on the other developer tools. So specifically for Qualcomm, we have multiple ways in which you can really optimize AI for our devices as well. One is our standalone offering of the QNN libraries, where developers can use Qualcomm neural network APIs to run their AI models directly on our platform. Plus, there are a lot of AI middleware companies like Olamas or LM Studios or anything LLM, where you can just get started with some of these AI models on our platform, but then use APIs later to highly optimize it for specific workloads.
Lina, can I add to that? So I think
Yes,
so
absolutely.
that one more tool in your toolbox. If you go to the Windows Store on a Windows ARM machine and look for AI Dev Gallery, it's a tool that we built from my team, and it shows you how to use not just the WCR APIs, which are the Windows Copilot Runtime. It's a crazy name, Windows Copilot Runtime. That's the inbuilt Windows APIs, which are backed by Silica model. But you can also shows how to get Hugging Face models on the device using Onyx Runtime and the Onyx execution provider on an ARM device, which comes from Qualcomm, to actually just go and build that. And when you've tried one out and you're ready, you hit a button and it will generate you a Visual Studio project with all the code you need to actually get that up and running. So it's a really quick, it's designed to be a really quick on-ramp to get you up and running with your first AI experience, using your models.
So, Francesco, at Blender, you have the vast resources of developers in front of you. What are they looking for when a new architecture comes into play, or somebody says, hey, we have one set of APIs here? Your Blender runs on pretty much any kind of hardware, any kind of operating system at this time. So what is your experience?
Yeah, it's very, this is interesting because you can look at this from many different angles. And so we have lots of developers, great. They are volunteers, not great. Okay, some of them are actually paid, great, but they are working on other things. Okay, then there is hardware. Nice, let's support this hardware. And this hardware comes with its own APIs and its own infrastructure. And then comes another hardware, which comes with its own API, with its own, and then comes another hardware, and then another one, and then another one. And this is kind of reality, like today, for example, for GPU computing. So you have like a situation with like CUDA, HIP, Metal, SQL, something else that is gonna be dropped down by aliens from space. And that's very interesting because with what resources do we manage this? And a lot of the purpose of Blender core development is to make sure that this thing comes together, finding the right levels of abstraction and so on to actually make this sustainable, or sometimes tries to steer things towards consensus and to work as much as possible with open standards and open source, because that's a lot of Blender's identity. So that's always a topic for us that is very embedded into the nature of the project itself. So like having, from a kind of strategy point of view, like we definitely want to make sure that Blender is future-proof and the Blender is available in the new places, in the new environments, even new interaction paradigms. And to do that, you need to be open to support new hardware architectures. So we do invest in that. The thing that helps a lot to make this happen is, of course, relationships with organizations that are able to seed hardware, that are able to seed engineering resources that can support the developers and that can help also a little bit with the funding of the project itself. Because then very often what does happen in reality is that you have core developers working at Blender, Blender Foundation, the project itself, collaborating with industry that maybe has some engineering, but then there are people from the community as well that can help with triaging, fixing things, improving things. Like the QA side of things, it's like one of the, it's not like the secret weapon, but it's like one of the best aspects of having a project like Blender and open source. And when you have a big community around an open source project, you get a level of scrutiny and quality, both for the development process, but also like from the end user experience, that is very high. And so like all these things, then they come together, and that's what then make possible going there. But it even also needs a lot of different types of resources to be put together to make it happen. So yeah, not sure if it entirely answers your question.
No,
I went a
it
little bit on a
answers it.
tangent, but
This is exactly the forum where you can
Yeah.
reach out to both developers and also to companies
Yeah.
To help
Yeah.
advance Blender.
We really do try like to reduce the load of, we call it kind of core development, so people that are really working on stuff to work on Blender. Of course, it's important to have people there that know the architecture inside out, know how things work, but the more there is ownership, distributed ownership of these technologies, the healthier things are in the long run, the more sustainable, the more stable they are. You don't want to end up in situations like where you have consortia and complicated, geopolitical level almost discussions, because that also then becomes a slowdown. So try to find a sweet spot, but that's very important and something that we feel is instrumental to Blender success.
Actually, I'd like to add one other thing.
Yeah.
You asked, this isn't really ARM's thing, but next week is Microsoft, excuse me, Microsoft Build, which is, it's sort of, I don't know, sort of the Super Bowl of Windows developers. That event, and there's a lot of content there. If you can't join, I think it's always about this time of year. But if you can't join, there's a lot of on-demand content to see as well. There's plenty of content there for Windows on ARM, sort of the latest stuff. I think I'm shilling for you a little bit here, but I would absolutely, I've gone the last few years. I will be there next week. It's a great event for developers.
There's a fantastic talk on Wednesday evening at 5 p.m. That's PT, so Pacific time. Chris Goodyear from ARM is talking about ARM optimization, and I'll help him out with that. So if you're interested in how to get the best performing app on Windows and ARM, there'd be a lot about porting in there as well and how to get that done. See if you can join in either then or catch up afterwards.
Yeah, I noticed Qualcomm has a handful of live sessions, and I'm sure there's
and
some.
ARM does too, right?
Yeah. So yeah, I'd absolutely encourage that for people who are interested in Windows development.
So we talked about the past, the pain points, and the current, and the developer resources available. I want to ask each and every one of you, what does the roadmap look like? Roadmap and Windows on ARM looks like to you. Let's start with you, Marcus.
So I think we're coming to a point where, well, I'd like to declare that we're ready in terms of an ecosystem. Are you ever ready? Are you ever done? No, I don't think so. I mean, there's always the next thing, and we have to keep moving forward. But our focus needs to change in terms of certainly the group we've got working together here across the ecosystem from, point picking specific libraries and specific technologies to actually focusing on performance. So looking at the compiler performances we've got, looking at the performances of core libraries and investing in those. And then, focusing maybe on some of the supporting technologies that Pedro mentioned this morning in QEMU and some of the other big ticket items to ensure that the quality is there and continues to move forward. And if I may, just a plug, the one area we're struggling right now in our core stuff is around GCC itself. I mentioned it. If anybody is interested in helping and moving this forward, that's where we need help. And it's a couple of years still to go before we reach maturity, and every oar, every paddle helps move us along that road.
Yeah. So from Qualcomm's perspective, the way I see it is, yes, the platform is ready, but what we also want to make sure is that, like any developer, a general developer or an AI developer or a gaming developer, they use these different tools across different domains. There can be like a low level driver level coding all the way to the application level, right? So there are not just the core tools that needs to be ready, but I think the way we have started looking is that how big this whole tools ecosystem is and how we can tackle the challenges for each of these developers. So that's what our roadmap looks like, and how to ease the pain points of all these developers so that there is an easy development process throughout their whole journey while building the apps, or even writing these firmwares or low-level drivers. Basically, we want to make sure all kinds of developers are covered.
My turn? Okay. I started this a long time ago. We initially were trying to get the Electron framework running, and ARM had a lot of expertise around Chromium, which is what that's based on, and it's it's used by Microsoft Teams and I think a number of other applications, and that's how I got started doing this, and really sort of came upon. There's a list of applications that, as a Windows user, that you expect to run well. So that's where we started. Like, are these guys blocked? Go talk to the Adobes and all those people that, again, that I'm sure everybody has that core number of apps that they expect to run, and that's how we started figuring out sort of these are the things that are blocked. These are where we need to focus. And I think our aim is to try to make the Windows on ARM ecosystem just the Windows ecosystem, where it's sort of just self-sustaining. What we really want to have happen is not to have to handhold ISVs. It's great when something just sort of pops out. It's like, hey, we now have support for Windows, and it happens to be on ARM. That's what we're trying to get to, and I think we're absolutely getting there. We are never going to be done. I think we're at a point where we want to start optimizing, making sure that what we're enabling is the best it can be. I think there's some non-obvious things. Just recently, the GitHub runners being available for Windows on ARM potentially unblocks a bunch of stuff. In fact, we have at Microsoft Build next week, we have an on-demand video that talks about what that did for the PyTorch. What it did for PyTorch is basically open it up and make it so that you could run it natively on Windows on ARM. So yeah, there's a lot of stuff that's still, there's little drips and drabs of things that we need to do, but I think we've made a heck of a lot of progress, and I'm looking forward to, again, the day when it just becomes just ARM is really what we're trying to shoot for.
So earlier this morning, Francesco and we were talking about Blender apps, and I have so far refrained from using the word AI in this talk, but he had some interesting AI-related roadmaps, so I want to have you talk about it.
So before we talk about the AI, I actually, by hearing what you guys say, because like this panel is a bit, there is a balance, right? There is like people that are building the world upon which indeed then the little software developers go and make something like Blender, which then can have a big impact out there in the world. And that is possible because of so much foundation that has to be laid before that's even possible. And then depending on the projects, it's really sometimes very obvious how much, like you say, let's try to limit the amount of handholding that we have to do so that people can actually do self-service. And you achieve that when you indeed have mature frameworks, good APIs, accessible hardware, et cetera, et cetera. And one thought that I had is for the future of what we do with Blender and in general is that we definitely want to continue working and being engaged directly with the organizations that are making these platforms possible. And I think it's important to leverage the unique position that open source software has, especially when it has a certain degree of maturity, because open source in the end is just a tool. It's not like that because you're open source then you're special. It's just like you have a certain degree of maturity and you can work together with others, and the solutions that you find, they are available for everybody. And we had this in the past happening with other vendors and other architecture designers saying, we are making this piece of tech, and for us, the goal is to make sure that it's available in Blender so that everybody can see what the state-of-the-art implementation of this technology is. And I think that that's really cool. And that's like one of the things that are possible in Blender and other open source software that is not otherwise. And it's, I think, a good strategy to kind of keep focusing on those things and try to develop them together, because then they can really help to scale these efforts better, because then people can actually look up, oh, how did they implement this? How are they taking advantage of this in actual, real production software with the complexity and the struggle that comes with it? So that's one thought that I had, and for me, it's very much in the future, and that's very much how we approach also growing and fostering the relationship we have with partners. And then, like, talking more a little bit about the visions for the future. AI is a very touchy subject, especially in the world of art and content creation, so making a tool that is meant to enable artists, we feel that very much. And nowadays there is, again, a lot of discourse on what is it, like, is it about Gen AI? Is it about other things? What we want to do is start with the fundamentals, start with the basics, things that are really not very controversial, and that are already available in many other softwares. You can think of upscaling, for example, or denoising, which is already partially available in Blender for some things, for rendering and so on. And make sure that those technologies, though, can indeed start to take more advantage of the specific architectures. And ideally, try to do it in a way that we don't need 6 different frameworks for each one of the hardware architectures that are out there. And that's like very, very important, because otherwise the software, like the project itself, like has some sort of, we need to keep the relevance of what we are doing. And if we want to help artists, and this technology exists out there in the world, we have to somehow make it available in a way that is still ethical and aligned with our beliefs, but at the same time that is also practical. They're also very practical. And so then in the future, you can think of other ways to do this too. For example, style transfer or other technologies that are a little bit more relying on models trained on content, but then giving people the possibility to train their own content. So of course, like the whole topic of training, in some cases you need like huge infrastructure to do it. But for example, for LoRa's and other things, you don't need as much. And so the ability to make that accessible, it's very, very enticing for Blender. Today there is this software that everybody knows, I think, Comfy UI, that shows what the Wild West of AI for artists look like. And then the goal for us is like to kind of make something that is more accessible, more easy to actually do, so that people have also more control. And that was like one kind of final thought about this whole AI stuff, that I try to broadcast this as far and wide as possible for people to know that it's interesting, of course, to explore these things of especially when it comes to generative stuff, but like being able to retain control for us, the artists, is super important. So also when you think of technologies, when you think of ideas to research and implement as tech, like think of how can someone harness this? How can they make it go where they want? It's not just about typing a prompt and then things magically happen. And that's like something that we really try to keep very much at the core of the vision around AI tooling and AI technology in Blender.
We have a few minutes left, and I want to open up for any audience questions for this panel. So, yes, Maxim.
This is a question primarily for Marcus. So when Windows on ARM hardware initially shipped, several of important Microsoft software projects were not natively ported to Windows on ARM, like Visual Studio, for example, and it was quite painful. What about now? Are all the important Microsoft software projects now native on Windows on ARM?
Thank you for that question. No is the answer. I tell you the truth. I mean, that's the thing, right? Isn't it? It's better to know the truth where we're at. So in terms of the developer products, I think the answer is largely yes. There are some specific areas where the answer is clearly still no, and the understanding of why and what the route to get that fixed is probably more interesting than the yes or no. So I pick one. I'll pick SQL Server. So SQL Server is an enterprise-grade product that we have traditionally run both locally in client-server setup and also in cloud setup now. The monetization teams around SQL Server prefer to run it in the cloud, and in that situation, you don't care whether it's available native or what it's running in the cloud, somebody else's problem. But as we've been working with teams like that, it's about trying to make them aware that developers that are building this stuff need to have the local capability of running these. Now, I picked SQL Server specifically because it not only doesn't run natively, it doesn't install either, and that is a blocker. So we've been working with that team, and actually I'll have a fix for that very soon. That's one example. But if you look around Microsoft, there are a few which are still working, but not native. And in those situations, it's generally because they felt that the emulated performance meets the size of market that they have on the hardware today. And we're continuing to work to persuade them that they're wrong and that actually they need to be ahead of the game. So yeah, good question. We're still working on it. There are a few. The good news is the developer tools, Visual Studio has now for 2 years. We had a thing called Project Wilson internally after, I think it was the inventor for ARM. I forget the details, but that was about getting developers up and running. And that completed in 23.
Great.
Does that answer your question, Maxine? Good.
Any other questions?
Actually, I have a question for Francesco. Was
yes.
that in that video you showed? Was that you up on stage accepting the?
It was not.
Oh.
I'm not that famous,
Oh,
but it's okay. Like if you come to the Blender conference later this year, maybe I try to get Gins, the director, to bring the Oscar, so then we can all take a picture with it.
Okay.
That's yeah.
The person who made the feature taught themselves Blender and did the movie.
Do you know the story of this filmmaker? Like, he's one guy. He started by making one film by himself, entirely, everything by himself, one person. And then for this film, he worked with a team of like 20 people, 25 people.
Is that the movie Flow?
Yeah,
Yeah.
So it's like amazing.
Pretty good.
Sorry, didn't mean to hijack it.
No,
It's fine.
I think
Here, more questions.
When Windows and ARM kind of first became public, there were a few attempts, I'm not sure how successful, to put out development machines, sort of Mac Mini size things you would plug into a monitor. Am I right in assuming now we're kind of past that era? So if I'm a developer, it's go get a VM on Azure, or it's buy a Snapdragon laptop for that sort of experience. We don't need specific development bots.
So the reason we created the Volterra, or rather I should call it the proper name, Windows Dev Kit
DevKit
2023.
2024. Yeah.
The reason we created that was because there weren't devices that were appropriate for developers. There are two key things. Developer generally wants everything they can squeeze out of the hardware. That means any thermal limitations on it are, get rid of them, don't want them. And the second thing is form factor. I don't need a screen, so keep the price low, and I need to be able to stack them in an acceptable way in a lab. And Volterra was designed specifically to target that. Volterra was a very expensive project for Microsoft to do, and when Microsoft says it's expensive to do that. And the ability to do a second version of that was prohibitive, so we decided not to. What we did instead was to look at our OEM ecosystem, which is exactly what we should be doing. And the OEM ecosystem at that time were not ready. So we worked with Qualcomm directly to attempt to fill that space, which unfortunately, for quite complex reasons, failed with the Snapdragon Dev Kit. But that doesn't mean to say we're done with it. There is still a market for developer devices. I recognize that. I continue to work on that. But the right place to solve it is with our OEMs. And so we've proven that if we try and do it with Microsoft directly, there's a lot of reasons why that's not a great idea. If we try and do it with the silicon manufacturers, there are a lot of reasons why that's not a great idea. But the OEMs understand the market, they understand the developers, they can monetize it, but at a price point that's acceptable because they've got history. And actually we can get a range of them so they can compete. So that's the direction we're going to solve that problem. I haven't got a solution for you today, but that is an ongoing conversation. Question from Pedro?
I'm just commenting that I think it was this week that Lenovo 90Q was launched with the 8-core version of the Elite Plus.
Yeah.
So
I'll just
it's a Mac Mini kind of a thing.
I'll just repeat that so that people heard. It's Lenovo, isn't it? That shipped. Yeah. So Lenovo had actually got 2 devices that they were planning, and the first one is now available. So they're not specifically designed it for developers, because if they were, and if they've asked us, I'd say, you put the X Elite 12 core. In fact, the developer edition with the extra 100 hertz.
32 GB RAM and 64 GB RAM.
Stick it all in there, but they're not aimed at that. They're aimed at something in between, and I assume that's because of commercialization and making enough money to justify it.
No, I think Marcus covered most of the points, but then there are still the laptops out there where you can still go and do the developments. But I've also met a lot of ISVs who still complain, who still ask, hey, we need dev kits. Like, I want to stack like 5 different dev kits on top of each other, and I want to start developing, right? So that's the scale they're asking for. It's an unmet demand, and there's still a lot of opportunities in the future for that. But I think there's definitely a scope that we'll look into.
I think we are at the.
One more.
Oh, there's one more.
question.
Oh,
Yeah,
yeah.
Okay, so when Apple just came to ARM,
Close.
they did it cold turkey, like they just gave up on x86 and started M1. And the adoption was much faster. With Windows and ARM, currently we have people with the choice. We have ARM devices versus x64 devices. I've seen people still choosing x64, and the low power is not yet a great driver for us to do bigger sales. So I'm just asking what you guys have in mind to drive the sales forward in future, apart from just the low power aspect of the Windows and ARM devices.
I guess I'll take that one. Yeah. So I'm a developer. I'm not qualified to answer that question. Let's start with that, shall we? In terms of driving it forward, Microsoft has a different view of its industry from Apple because we have a different set of customers. We have different demands. We have different history. There's so many different things in our ecosystem of customers make it inappropriate for us to follow the same route that Apple took, which means that it's right for us to offer a range of silicon and allow our silicon vendors and our OEMs to compete where they are best innovating. So if the silicon vendor can produce a chip that's fast enough that everybody wants to go buy that chip, fantastic. If it's Qualcomm, that's even better for me. If it's Intel, that's just as good for Windows, and it's in fact good for the ecosystem. What my job is, what our job is to make sure that that decision by our customers is based upon the capabilities of the hardware and not the limitations of the software. And that's what we've been engaged in. So success for me is when somebody comes into Best Buy or Curry's in the UK, I don't know what it is here, and actually goes and looks at 2 devices next to each other and goes, oh, that one is quicker than that one, I'll buy it. And they didn't ask what the chip is, and they didn't care, and it just worked.
Great answer from Microsoft. But Qualcomm views it a little bit differently, right? The way we want to scale is, of course, drive the adoption and sell more devices out there. It's hard to, there's an ecosystem that exists out there in the x64, and they have been in the space for like 30 years. So it's not easy to just flip around, and especially Microsoft supports all the platforms. There is head start for them, but then there is a catch up for us. So in all the efforts, we are definitely trying to make sure the ecosystem is growing and people do find value. I love the fact that which one is faster and people want to go for that, and I want that to be X Elite, Snapdragon. But we'll get there. I mean, it's a matter of time, but the ecosystem and everything else is looking strong, is all I can say.
Can I just add a super quick thing to that? Because actually you were saying it's a matter of time, which just for a frame of reference is when Apple did what they, this very aggressive switch and started to come out with these devices, and there was a lot of interest in making sure that DCC would work on that, the level of performance and quality of user experience at the beginning was, I mean, what you would expect from a first generation product. And if you track the time that it took to get to a point where you can now get, the latest laptop, and it actually, you are looking at it like, that actually starts to work. Very interesting. So how long did it take? Well, almost 5 years. And that's like, you can then try to extrapolate the amount of resources I put in, the whatever, right? All those challenges. But like, it does indeed take a few years, but it's definitely, at least speaking from experience as someone that has seen that on that platform, it works. So it's very encouraging. So just, it's not those things that you can do quarter by quarter, though. It requires a little bit of a longer horizon, like yeah.
Thank you so much. A big round of applause to all the